For 30 years, this machine was treated like a mistake. Rival engineers laughed at it. Salesmen at other companies used it as a punchline. Farmers were quietly warned to stay away. Nice idea, wrong design, it'll never scale. And they weren't entirely wrong. This machine had a flaw baked into its very shape, a flaw that should have killed it, a flaw that on paper made it a dead end the moment it rolled out of the factory in 1979. But here's the part nobody saw coming. 30 years later, one by one, the same companies that mocked it started chasing the exact idea they said was impossible. The design they called a joke didn't just survive, it outlived 3 of the corporations that owned it. This is the story of a machine that was right, decades before the world was ready to admit it. To understand why it almost destroyed a legendary American brand and then saved it, we have to go back to a field in Kansas, a secret lab in Detroit, and a patent that slipped through somebody's fingers. Stay with me, because the twist in the middle of this one is genuinely wild. Let me set the scene. The late 1970s. For 100 years, harvesting grain worked one basic way. You had a spinning drum, a cylinder, that beat the grain out of the plant. Simple, reliable, and slow, because everything had to happen in one violent instant as the crop passed through. Then, in 1977, one company blew the whole thing up. International Harvester released a combine called the axial-flow. Instead of beating the grain out in one pass, it took the crop and spun it down the length of a long tube, threshing it over and over gently in a spiral. More grain saved, less damage, way more capacity. It was a genuine revolution, and every major manufacturer had the exact same thought. We need one of those now. So the race was on. Everybody started building their own version of that long front-to-back spinning tube. Case, New Holland, all of them, copying the same blueprint. Everybody except one company, because while the entire industry was zigging, a stubborn brand out of Kansas was about to zag so hard it would spend the next 3 decades as the underdog. And to understand why they did something so seemingly reckless, you need to know who they were. Their name was Gleaner, and they'd been keeping a secret since the 1930s. Gleaner was founded in 1923 by 3 brothers named Baldwin, farmers out of Nickerson, Kansas, and these guys were inventors. They built one of the first genuinely reliable self-propelled combines in America. They even named the company after a painting, The Gleaners, about poor workers picking up the grain the harvest left behind. Kind of poetic for a company that would spend its life as the scrappy one picking up what everyone else missed. But here's the detail that matters. One of those brothers, Curt Baldwin, had an obsession. Back in the 1930s, decades before anybody was seriously building rotary combines, Curt was already filing patents on using spinning centrifugal force to thresh grain instead of just brute impact. Read that again, the 1930s. This is a man dreaming about rotary technology 40 years before International Harvester made it famous. So why didn't Gleaner invent the rotary combine first? One reason: power, or the lack of it. Curt chased this idea his whole life, prototype after prototype. But the engines of that era simply couldn't push enough horsepower to make a rotor spin the way the design demanded. He had the vision, he didn't have the muscle, so the idea just sat there, a ghost inside the company's DNA, waiting for decades. Now fast forward to the late 1960s. Gleaner is owned by Allis-Chalmers, and a team of engineers dusts off the old dream. Turbocharged diesels finally exist. The power problem is solved. They build a rotary prototype, and it works. But it doesn't look like anybody else's rotary. Not even close. And why it looks so different comes down to a story that, to this day, some people in the combine world swear is true and others say is a legend. It involves a secret lab, a fired scientist, and a patent that got away. I have to be straight with you here, because this next part lives somewhere between documented history and folklore. Longtime Gleaner people tell this story like gospel. Take it with the appropriate grain of, well, grain. In the mid-1960s, in the Detroit area, there was a small, hush-hush group of combine engineers working for a different company, Massey Ferguson. This team, led by a doctor named Alex Marks, was cooking up ideas years ahead of the market. 2 of those ideas would go on to define an entire brand. The first was a transverse rotor, a threshing rotor mounted sideways, running across the machine instead of front to back. The second was a device called accelerator rolls, rollers that fling the grain downward at incredible speed to help clean it in mid-air. And then the whole thing collapsed. Dr. Marks was let go, The Detroit Combine project was shut down. Massey tried to patent the technology, and here's the gut punch. The patent attorneys reportedly blew it. They were told you can't patent a principle, only a specific application of it. The claim failed. The door was left wide open. So what happens to a brilliant, unpatented idea when the company that created it walks away? Somebody else picks it up. As the story goes, Dr. Marks took his research and joined Gleaner and convinced them to build a combine around a concept the rest of the industry had never even considered. True in every detail? Maybe not. But one fact is not in dispute. While every competitor on Earth was building their rotor to run front to back, Gleaner turned theirs sideways. And in 1979, they bet the entire company on it. February 1979, Gleaner pulls the sheet off a machine called the N6. And to anyone who understood combines, it looked like heresy. Let me make this crystal clear, because it's the whole point of the story. Every rotary combine ever built, Internationals, New Hollands, everybody's, took the crop coming in the front and forced it to make a turn, funneling it into a long rotor running the length of the machine, front to back. Axial. Gleaner refused to turn the crop at all. They mounted the rotor across the machine, perpendicular to the direction you're driving, so the crop came in the front, spread out into a flat, even ribbon, and hit a spinning rotor going sideways. No sharp turns, no funneling, no corners to jam up in. They called it natural flow, because the crop never had to change direction. It just flowed straight through in one smooth, uninterrupted ribbon. Now, you're probably thinking, okay, cute, but so what? Here's so what. That single design choice unlocked a stack of advantages competitors literally could not match, and the gamble paid off big right out of the gate. A few months after the N6, Gleaner dropped a smaller model, the N5, and late in 1979, they rolled out the monster, the N7. The N7 wasn't just big, it was, at that moment, the largest combine you could buy in North America, and it held that crown for 20 years before any competitor could match its capacity. So the reckless bet started out looking like pure genius, which raises the obvious question. If it was so good, why did people spend the next 30 years calling it a mistake? Hold that thought. Because first, you need to see just how good this machine actually was. Number one, it threshed the grain all the way around. An axial rotor only wraps the crop against a threshing surface for part of its circle, roughly 150 to 180 degrees. Half the rotor is just carrying material. Gleaner's transverse setup wrapped the crop a full 360 degrees, the entire circumference doing work, which meant Gleaner could do in one pass what an axial machine needed 2 passes to accomplish. Number two, the ribbon effect. Because the crop never changed direction, it stayed in a flat, even mat the whole way through. Every axial design has a high wear danger zone, right where the crop is violently forced to turn into the rotor. Gleaner just didn't have that zone. No turn, no wear point, no jam point. Number three, and this one's my favorite, the accelerator rolls. Gleaner fired the grain downward at 1,500 feet per minute, slung into a thin, fast-moving sheet, blasted with air before it ever reached the cleaning shoe. 2-stage cleaning, with most of the work done before the traditional cleaning even started. Number four, the low center of gravity. Because that rotor sat low and sideways in the middle, Gleaner wrapped the grain tank around it and kept the weight down low, giving it stability on hillsides that made high-riding competitors nervous. And number five, the party trick, the rock door. Every combine eventually swallows a stone. On most machines, that rock gets trapped and the operator has to climb down and dig it out. On a Gleaner, a little door at the front just pops open and spits the rock back onto the ground. Keep driving. Don't even stop. So let's tally this up. Full circle threshing, 0-turn crop flow, 2-stage air cleaning, rock-proof, slope-stable. The most productive combine in America. This should have been the machine that conquered the industry. So why did Gleaner spend the next 3 decades bleeding, getting bought and sold, and treated like the weird kid at the lunch table? Because hidden inside that beautiful sideways design was a trap, a wall Gleaner could not climb over, and their competitors knew it. Here's the flaw, and it's brutal in its simplicity. Every year, farms got bigger and farmers wanted more capacity. If you build an axial combine, the front-to-back kind, increasing capacity is almost embarrassingly easy. You want more? You just make the rotor longer, stretch the tube. The machine gets a little longer, but who cares? It still fits down the road. That's the entire reason the industry loved axial. It scaled infinitely practically. Now look at Gleaner's sideways rotor. It runs across the machine. So how do you make it bigger? You'd have to make it longer, which means making the entire combine wider. And there's a hard ceiling on width. It's called the road. You can only build a machine so wide before it can't legally drive on a public highway, can't get from field to field. Gleaner slammed into that wall almost immediately. Their rivals could grow their machines every single year just by stretching the rotor. Gleaner physically could not. Engineers, including Gleaner's own, became convinced the transverse combine had simply hit its maximum. In the eyes of the industry, a technological dead end, and the market punished them for it. Ownership started churning. In 1985, Allis-Chalmers sold the whole farm equipment business to a German company, and the brand became Deutz-Allis. Then in 1991, the North American operation was folded into a new company, AGCO. And through all that turmoil, between roughly 1985 and 2000, Gleaner hemorrhaged market share to competitors with bigger dealer networks and machines that could grow every year. The company that once built the biggest combine in America was now the shrinking underdog, chained to a design everyone said had no future. And then, right at the lowest point, Gleaner did something that felt like a betrayal of its own soul. Around 2007, AGCO finally cracked under the pressure. They released a pair of combines called the A5 and A6, wearing the Gleaner badge. That silver, that name, that heritage, going all the way back to the Baldwin brothers in 1923. But under the sheet metal, these machines were traitors. They didn't have the sideways rotor. They didn't have natural flow. They had a conventional front-to-back axial processor, the exact design Gleaner had spent 30 years defining itself against. Rebadged versions of machines AGCO already built under other brands, wearing the Gleaner name to lure in customers who wanted a normal rotary. The company that bet everything on the sideways rotor was now quietly selling the very thing it had sworn was inferior. To loyal Gleaner people, this looked like the end. Like the gamble of 1979 was officially a loss, and the sideways rotor was about to be retired into history as a noble failure. Clever, but wrong. But here's the thing about that width wall, the one everyone swore was unbeatable, the one that had trapped Gleaner for 3 decades. While the A-Series was rolling out the front door, a group of AGCO engineers were staring at that wall, and they were about to notice something everyone else had missed for 30 years. For 30 years, everyone, including Gleaner, assumed there was only one way to make a rotor bigger: make it longer. And since the rotor ran sideways, longer meant wider, and wider meant illegal. Dead end. But the engineers in 2008 asked a different question, a stupidly simple one nobody had cracked in 3 decades. What if you don't make it longer? What if you make it fatter? Not length, diameter. Instead of stretching the rotor across the machine, they increased the size of the circle. And because Gleaner's rotor threshed the full 360 degrees, remember that? A fatter rotor meant a dramatically longer threshing path without adding a single inch of width. They'd found the loophole. The wall wasn't a wall, it was a locked door, and they'd finally found the key. The result was the Gleaner Super Series, and it changed everything. The transverse combine could grow again, gaining capacity without getting heavier, without getting wider, and actually cutting fuel use per bushel in the process. The design everyone said had maxed out in 1979 had just been waiting for someone to solve the diameter problem. The idea was never wrong. The engineering to unlock it just didn't exist yet. And here's the full circle moment. Gleaner went on to build the world's first Class 8 transverse rotor combine, the top tier of harvester size, the very biggest class. On the sideways rotor, everyone said could never scale. Meanwhile, that traitorous axial A-Series, the one supposed to be the safe, modern future, Gleaner killed it. Production ended around 2010. The brand walked away from the axial machine and went right back to the design it was born with. The sideways rotor didn't just survive, it won. So let's answer the question we started with. Why was this machine too early for its time? Because in 1979, Gleaner had the right idea and the wrong decade. The transverse rotor's core promise, full circle threshing, gentle handling, a low, stable, efficient machine, was genuinely superior from day one. Curt Baldwin basically dreamed it in the 1930s. The concept was decades ahead of the tools available to build it. The design's one fatal weakness, that it couldn't scale, wasn't actually a weakness of the idea. It was a weakness of what engineers in 1979 knew how to do. The solution existed the whole time, hiding in plain sight: It just took the industry until 2008 to figure out you grow the rotor's diameter, not its length. Think about that gap. Nearly 30 years where a great machine wore a failure label, not because it was bad, but because the world hadn't caught up to how to use it. And when the future finally showed up, the machine was still standing. It outlived Allis-Chalmers. It outlived Deutz-Allis. It's still in production today under AGCO, and as recently as 2024, they launched a brand new version, the T-Series, still riding that same stubborn sideways rotor first bolted into a combine in 1979. The companies that laughed are gone or absorbed. The joke design is still harvesting fields across 3 continents. That's the strange, quiet lesson of Gleaner's rotary gamble. Being right isn't always enough. Sometimes being right too early looks exactly like being wrong, for years, for decades, until one day someone finally asks the simple question everybody else was too busy to ask, and the whole world realizes the underdog was never behind. It was just waiting. If this one pulled you in, there are a dozen more like it. Brilliant machines the world gave up on right before they were proven right. Stick around and I'll show you the next one.